Hello guys, this video is part of a series on web development. In the previous videos we've been looking at Rails, and I must say that working with Rails taught me a lot, and I think that's a great tool. But I found that it had some issues, and that left me still looking for a faster and easier way to write applications. One of the key problems is the SQL database that Rails is built on. SQL databases are also known as relational databases. These databases are organized into rows and columns, just like a spreadsheet. This is great for many applications, especially if your application naturally fits this model. For example, if you are building a financial application that is built around a list of transactions, this can be a really good fit for a SQL database. I mean, if you have a look at this this journal, you can see that this kind of data is going to fit very naturally into a table, into a database that's made up of tables. But it's a problem if your application doesn't naturally fit this kind of a model, and most applications, I would say, don't fit this kind of tabular model. So take, for example, a recipe book website. So this website will have recipes, and each recipe will have a list of ingredients and a list of steps to prepare the dish. This type of data does not naturally fit into the table model. To store this data in an SQL database, you must split the data up into several related tables. To access the data, you have to reassemble the data by joining the data in the tables. To use more technical language, you have to transform your data from one shape into another before you can use it. This layer of transformation code is time-consuming to write, and if you change anything in your application, especially in your database, you're going to have to update this layer of transformation code, which can make your applications difficult to change. This layer of transformation code is where object relational mapping patterns come in, or where the object relational mapping pattern comes in. And there are very sophisticated ORM frameworks that have been developed, like Hibernate, and these take a lot of pain out of this transformation task. But still, they're treating the symptoms while the underlying problem remains. So the next big step forward for me was starting to work with NoSQL databases. You'll also hear these databases referred to as object databases or document databases. The one that I work with the most is MongoDB. So let's jump into some code, and I will try to show you how much time you can save using an object database. Okay, so our application is going to output this. So here is a recipe, title, a list of ingredients. Each ingredient has a quantity, a unit of measure, and the actual ingredient, and a list of steps to produce the meal. The code to create this is really simple. Okay, so here it is. This is just a little bit of JavaScript code that basically outputs that we've just seen. Okay, and this code takes a object as input, a recipe object, and here is the recipe object. Okay, so you can see in this object all of the pieces of data required to produce this output. Okay, so it's a very simple little program. Right, so let's start with the SQL database. I'm going to be using MySQL. Okay, so the first thing I need to do is I need to figure out how am I going to store this data in a database that's made up of tables. and I can't use a single table. I'm going to have to use multiple tables, and I'm going to have to link those tables or relate those tables together. So for those of us who've been working with SQL databases quite a lot, I think maybe we get used to this process, and we don't realize just how much effort it actually is to do this kind of a translating an object into a set of tables. So let's go ahead and do it. By the way, this is my second take because I got myself horribly tangled up the last time. But I didn't want you to have to sit and watch me getting all tangled up. But it does just illustrate the point of how this is a complicated thing to do, and I would say an unnecessary thing to do. So this is our recipe table. It's got an ID. It's going to have a name, right? Apply that. Okay, but we're going to need another table, an ingredients table. Okay, so let's go ahead and create the ingredients table. Right, this is also going to need an ID, and you know, I'm thinking to myself, well, why do we need two IDs? We've already got an ID for our recipe. Why do we need an ID for our ingredients as well? But this is what you need if you're splitting the data up into multiple tables. It's going to have a name, the name of the ingredient. It's going to have a measure, unit of measure. Just seeing if I can zoom this in a bit for you so that you can see it a bit better, but I don't think so. Okay, it's going to have a unit of measure, and it's going to have a quantity, which will be an integer. Okay, name, unit of measure, and quantity. Now what we're going to need to do is we're going to need to relate these two tables together, the ingredients and the receipt and the recipe table. So we're going to have to put in the recipe ID. Okay, and we're going to have to declare a foreign key to maintain referential integrity. Okay, foreign key, I think this is just a name. Ingredient, recipe, foreign key. Okay, and on delete cascade, and of course we need to do this so that, you know, if we go and delete a recipe, that the ingredients are deleted as well. So that's an additional piece of complexity. Apply this and hope that it all works. Okay, that looks like it's right. Okay, and then I go through the same process for the list of steps. Create a table called step ID column primary key, and the step description, which we're going to need quite a few characters for this, maybe say 2,000 characters. Okay, and we need to put in the recipe ID, the recipe that this relates to. This is an integer. Step recipe foreign key, referencing the recipe table, recipe ID, on delete these as well, and I hope this is going to work. Great. Okay, so we've now created we've now created our data model in our SQL database, and we've modeled it using tables. Okay, so we've ended up with 3 tables related, a bit like this: recipe, ingredient, steps. And so let's put some data in here. Okay, so let's create this. Let's insert this data into this database. And in order to do that, we're going to have to write several insert statements. So I'm going to just pause the video and write the insert statements, and then we can talk through them. Alright, so I've written my SQL statements to insert that data into my database. I'm going to go ahead and run these statements. So first of all, I insert the recipe into the recipe table, then I add all the ingredients into the ingredients table, and then all of the steps into the steps table. So let's go ahead and do that. Hopefully that's going to work. Okay, no it didn't. Right, so okay, I've inserted my recipe. Let's see that. Right, there it is, ID 3. Okay, and I just need to update these recipe IDs to 3. Just so the tables are linked up properly. Okay, let's see how that goes. Okay, great. So we've got our recipe in the recipe table. Whoops. Got our recipe in the recipe table. We've got our ingredients in the ingredients table. And we've got our steps in the step table. Right, next up we're going to have to write some code in order to read this data out of the database and print it onto the screen in a nicely formatted. So I've got two little projects prepared. They're written in Node.js, and they're basically almost identical. So I've got a bit of code to connect to the database and to get my recipe out of the database. Okay, I've got the error handling code that you need to put in for JavaScript. Okay, get my recipe out of the database with the recipe ID. The recipe ID is 3 actually. That's this recipe ID here. Okay, get my recipe. Okay, if the recipe is found, right, then just log out the raw object and print out the recipe. Okay, and print recipe is where this code is running in order to print out my recipe nicely. Okay, and get recipe, the get recipe function I've left just unimplemented, which we're going to fill in now with the details to get this recipe out of our MySQL database. So let me run this and just see what we get if I try and run this. Okay, recipe not found. Right, so let's go ahead and start the process of reading this recipe out of the database and joining the tables together so that we get our object that we require, this object that we require. So we need to create this object. So the first thing that I'm going to do is going to look at my notes on the side here so I can cheat. Okay, so the first thing that I need to do is I need to read this recipe out of the recipe table. So let's go ahead and do that. All right. Right, so this statement here is basically doing exactly what this statement here has done. Reads this, it returns this table to us here in recipe rows. I need to check for errors, as always, in the JavaScript program. Okay, and assuming I get a recipe back, I'm actually going to do this the other way around. So if I don't get a recipe back, I'm just going to call back no error, but also no recipe. Okay, so assuming this select statement actually returned me a recipe, then I can go ahead and look up the ingredients. Okay, so select star from recipe book.recipe where id equals 3. Okay, that's what that code will have done. Right, and assuming I get a result back, I can come through to the ingredients table and say select star from ingredients where recipe id equals 3. Okay, which returns the ingredients for that recipe. So let's go ahead and do that. Okay. So this is then going to be ingredient rows. All right, and finally we need to get our steps. Where recipe id equals 3. Okay, db.query the recipe ID and the callback. So if you're not really familiar with JavaScript, you'll probably be feeling a little bit confused at this point, and that's exactly the point, I think, of why I don't like using SQL databases for this kind of thing. Step rows. Right, so at this point we've run our 3 SQL queries, the one to get the recipe, one to get the ingredients, one to get the rest to get the steps. And now we can assemble our recipe object. So remember, this object is ultimately going to look like this. So let's go ahead and assemble it. There's only one row in that array of recipe rows. The name, recipe rows, dot, the first record name. Okay, the ingredients. Okay, which we'll come to in a moment, and the steps, which we will come to in a moment, right? Okay, so let's just get these ingredients. So what we're going to do is ingredient rows dot map ingredient get the name, quantity, and the measure out of this object, and return this as an object. All right, and for steps, step rows dot map step dot descriptions. This would then just be a simple array of descriptions. Okay, so this, I would say, this is code that I would call complicated and you know, a source of possible of bugs, and you know, code that I really would rather not write. Right, finally, we just need a callback, no errors, and we call back with our recipe object. And if I've typed this all out correctly, it will work. So let's just see. I've kind of got my doubts about it, if it's going to work first time. Okay, and probably because I've practiced this now 2 or 3 times, it has actually worked first time. And what it's done is it's printed out this object that we've just created here. There's the object there, printed out, raw object. Okay, and there is it nicely formatted for us. Okay, so there you go. That is our implementation using SQL. Okay, of our get receipt function, having to get the data out of 3 tables and join that together into a single object. Right, so let's go ahead and complete the same task using a NoSQL database or a document database or an object database. So remember when we were using a SQL database, the first thing we needed to do is figure out how do we store our data model for our application in a database made up of tables. Well, with an object database, we don't need to worry about that because we can store this object straight into the database. So I've got, we're using MongoDB. I've got my little MongoDB client here. I'm going to create a new database, call it recipe book. Now, in a document database in MongoDB, whereas in a SQL database like MySQL, you've got the concept of tables, in a NoSQL database like MongoDB, you've got a concept of collections, which are pretty much similar to tables. So I'm going to go ahead and create a new collection. And my collection is going to be called recipes. Now, this is, even though it uses a table symbol here, a collection is not really a table because a collection contains objects. So if I double click on this, okay, it found 0 records. Okay, I can go ahead and insert an object into this database. I basically just take this, oops, I basically take this object, and I put this object straight into the database. Okay, so if I do a query on my database, db.collectionReceipts.find. There you go, there's my object sitting in my database. Okay, so there's no creating tables, no creating foreign keys, no relating tables together. It's just create a database, create a collection, and stick the object straight into the collection. Okay, so that's considerably simpler than what we had to do with the SQL database. Right, and now let's go ahead and in code, let's get this object out of the database so that we can use it in our application. Okay, so I'll close that down and open up my NoSQL project. Right, and what I've got here is exactly what we had before. Okay, so we've got a function to connect to the MongoDB, very similar to what was there with the MySQL. Okay, we've got our call to get recipe. Okay, and we're printing out the raw object, and we're printing out the recipe, and there's the code to print out the recipe, exactly the same as with the other example. And here's our little function placeholder, and it's waiting for us to implement it. So let's go ahead and code the get recipe function using MongoDB. Okay, so db.collection recipes dot find one. Basically, I could just copy this straight out of here. Okay, find one. And now I need to put in my query. Okay, so I'm looking for the recipe with ID 1. Okay, so my query is an object. This is the field and the value, ID 1. Okay, so it's a different way of querying a database from the SQL way. And what we're getting back from the database, if I have a look at my SQL code from the previous example, what we got back from the database was a set of recipe rows. Okay, what we get back from the database is our recipe object, this recipe object here. Okay, so no transformation required. We get it back exactly as we need it. So I'm just going to put in my error handling code, which is what I need for all of my for JavaScript. Okay. And I just return my recipe. That's it. So let's see if that works. Let's go into my NoSQL folder. Just clear screen. Okay, yes, and that worked. Printed out exactly the same result. Okay, the raw object is exactly the same, and the output is exactly the same. But as you can see, there's no transformation required. So there's none of that having to query 3 different tables and then join our results up and transform them into the recipe object that we require. The recipe object that we require is stored directly in the database, exactly as we require it, and we just need to find it from the database. The database returns it to us straight, and that's it. No transformation required. So this is this move towards NoSQL databases has made a really big difference for me, because especially as an application grows in complexity, and you start having multiple tables and multiple different views and user interfaces that you need to create. This layer of transformation code that we have to write, this code that we have to write here, this code grows and grows and grows and grows until you've got quite a lot of it in your application, and it becomes a real stumbling block, because I think the thing that really makes things difficult, makes life difficult, is what if you need to change your data model? So what if I want to come along and I want to add, and I want to change this? So I want to add some new thing in here, like links to where you can buy the stuff online or something like that. Okay. Well, in that case, what I'm going to have to do is I'm going to have to go and I'm going to have to change my SQL database. Okay, I'm going to have to refactor this, and I'm going to have to refactor this code, and then I'm going to have to test this code. Okay, and that is very time consuming and very stressful task, and that just puts a stumbling block in the way of changing your program. Now imagine I want to add a list of links to where you can purchase these ingredients online to this, and I'm using a NoSQL database. Well, if I want to do that, well, I can just go ahead and do that. I change nothing in my database because the objects are saved in the database with this additional data. That's it. I don't need to change any tables or add any tables or do anything like that. And I don't need to change any mapping code at all. My recipe objects still come through. Okay, they'll have a few additional fields, but that's not going to affect anything in my program. So I can go ahead and I can quite happily make these kind of backward compatible changes without having to worry about testing all of this object relational mapping code. And that has made a really big difference to my software development. So I'm going to put a link in the description below to a great video by Martin Fowler. We're talking about NoSQL databases, and if you like the video, give it a like, and also think about subscribing so that you get notifications of new videos. Thanks for watching.